Hey, Mr. Miller here. So this video is about the origin of the first living thing. Now, up until this point, we've talked a lot about what atoms and molecules are. We've talked about biochemistry. We've talked about what you need in order to make life, but we haven't actually talked about the theories on how the first living thing came around. So before we can know that, we really need to understand what it is that living things are made up of and what things that you need in order to create life. So organisms are living things, and organisms are made up of organ systems. And organ systems are made up of organs. Organs are made up of tissues. Tissues are made up of cells. Cells are made up of molecules. Molecules are made up of atoms. And atoms are made up of protons, neutrons, and electrons. And you could keep going further down, but once we get past this point, things start to get a little haywire. So we're going to stop there. So all of Unit 1 was talking about these three things here. These three levels of organization of life. So as you can see, we start off really complicated at the top. And then as you go back, these complicated things are made up of slightly less complicated systems, which are made of slightly less complicated systems, which are made up of slightly less complicated systems, and so on and so forth. So it gets more and more simple as you go down. Now, life and the origin of life is the same way. Life today is very complicated, and I don't just mean just life being complicated, but I mean life forms, organisms. There are so many different kinds and varieties, and they're so intricate. So today it's very complex, but if you go back in time and you look through the fossil record, you see organisms become more and more simple as you go back in time. So it only stands to reason that at some point in time, we reached the smallest simple organism that you could possibly have and still be considered an organism, which is cells. And I know I just said organisms was way up here, okay? But there are such things as single-celled organisms like bacteria, for example. Bacteria are single-celled organisms. So the very first life form on Earth must have been a single-celled organism that we call a bacteria. And in fact, there is a special classification within bacteria, a very special group of bacteria, which we gave their own classification to. And they're actually called archaea. Now the word archaea means ancient. So these archaea bacteria, we actually have fossils of these archaea bacteria going back 3.5 billion years. Now Earth is only 4.5 billion years old. Now I say only, but in a galactic sense, that's really not that long. The universe itself, we think, is about 15 billion. The Earth, we think, is about 4.5 billion. And life, as far back as we know it, goes all the way back to 3.5 billion. So for the first billion years, which is an unimaginable amount of time, just that in itself, that's just how long Earth went without life. And it's had 3.5 billion years since. So these are the first life forms that we know of. And they're very simple cells But cells are made up of molecules. Molecules are made up of atoms. Atoms are made up of protons, neutrons, and electrons. Now, more specifically, we've already talked about these. We've talked about the different kinds of molecules. So there's actually 4 different kinds of molecules that make up these ancient bacteria, and still everything that exists today, every living thing that exists today is made up of some combination of these 4 biomolecules that we call carbs, proteins, lipids, and nucleic acids. So when we talk about the biomolecules, this is the level of classification that we're talking about. Larger than atoms, smaller than cells. So cells are made up of some combination of these 4 molecules. But molecules are made up of atoms. Which atoms? We've talked about it before. There are actually 5. 1, 2, 3, 4, 5. In earlier videos, we talked about just 4, but if you're here in class with me, I threw in a 5th one because it's involved in DNA, which I left out the first time. I was taking baby steps, okay? But the 5 are C-H-O-P and N, or chopping. Just remember chopping. We've got carbon, hydrogen, oxygen, phosphorus, and nitrogen. So these 5 atoms put together in different combinations make up molecules, specifically the biomolecules, of which there are 4 kinds. And these biomolecules, carbs, proteins, lipids, and nucleic acids, get put together in different combinations to make cells. The first known cell is this Archaeobacteria 3.5 billion years ago. So how did we get, though, from molecules, everything up to here, up to this point right here, these are all non-living. So how did we get a living cell from non-living parts? Well, this is called the Abiogenesis Theory. Abiogenesis. Now, when I say theory, I don't mean like in everyday speak. When you say theory and you're talking to a friend, you say you have a theory. That's just an idea you haven't tested it, okay? In science, it's the opposite. In science, an idea you haven't tested is a hypothesis. But no one says, hey man, I got a hypothesis about what happened. A hypothesis in science, you haven't tested it, but once you've tested it and you've gotten a result, and someone else does the same test, same experiment, gets the same result, and someone else does the same thing, gets the same result, and that happens enough times, over time, that becomes a theory. So a theory is not, in scientific terms, it's not something that was just pulled out of thin air. It's something that's been tested, been verified by different people in different places over a long period of time. So this abiogenesis theory, A means not, bio means life, genesis means creation. So it's creation of life from non-living things. So what do you need, again, as a reminder, to make living things? Well, you really only need 5 elements. Remember, you need chopping. So the abiogenesis theory states that in early Earth's atmosphere, we know for sure that all of these elements were present. All of these different types of atoms were present in early Earth. So the question was, can we take these elements that are non-living and can we put them together to make living molecules? Well, there's two scientists that set out to see if we could do that. And their last names were Miller, great last name by the way, Miller and Urey. So these two scientists said, okay, we're going to take these elements and we're going to put them into a chemistry set. We're going to add heat because early Earth was very hot. We're going to add electricity because early Earth was very stormy and there was lightning for sure zapping around all over the place. So we're going to put these things together with heat and electricity. We're going to recreate the conditions of early Earth, and we're going to just see what happens. And lo and behold, after doing this, these things plus heat and electricity, they actually created 11 different amino acids, which, if you'll remember, are what make up proteins. When you put them together, you make up proteins. So, we've got, like I said, we need carbs, lipids, proteins, and nucleic acids. So, we know you can make proteins. Check that off the list. And if you can make proteins from these elements with heat and electricity, then there's no reason to think that you can't also make lipids and carbs. Why? Because they're made up of the same stuff. If these different elements can come together in the presence of heat and electricity over time to make those, there's no reason to think that they can't also come together in different combinations to make these guys here. So if you can make these, we know we can make these also. So we've got 3 of the 4 biomolecules, the molecules necessary for life, already right off the bat from this one experiment. Now we just have to figure out, how do we get these? So in 2013, there were 2 scientists from Georgia Tech. I can't remember their names, but if you're out there and you're watching, you're probably not. But if you do, congratulations, and sorry I can't remember your names, but you should look them up. They figured out that RNA, remember RNA, that single-stranded nucleic acid? Which, by the way, if you can create these guys, there's no reason to think that you can't create nucleotides. Because nucleotides are also made up of the same stuff. And if you can make nucleotides, those nucleotides can come together to make RNA. Because that's what makes up the nucleic acids. So, what these scientists figured out is that when you put RNA in an atmosphere with no oxygen, it actually does something that we had no idea it could even do. It folds up on itself and looks and performs much like DNA. Now, whether or not this is truly the first DNA, we know we can have RNA, but we still need DNA. Whether or not this is truly the first DNA, I don't personally know. Not as of the date of this video. But it stands to reason that if RNA can do this in an atmosphere much like early Earth, with no oxygen in it. And we can make the rest of these things. That is very possible that all four of these molecules could have come together to make the first living cell.